Using Spotless water for spot-free automobile washing, window washing, cleaning electric photovoltaic cell, mirror washing and services requiring softened water or demineralized water. Water is known as the universal solvent because water will hold just about every chemical or substance on the planet to some extent. That being the case, some chemicals and other contaminants are slightly soluble. Lime is one of those chemicals. Calcium carbonate, lime, is a slightly soluble compound in groundwater. Most if not all groundwater has some lime as a part of its makeup. Surface waters have lime in them too. Lime is the compound that gives water the aqua coloration you see in oceans like the Caribbean. Water softening. Water softeners remove the calcium component of lime as well as magnesium, iron, and other soluble heavy metals. Carbonate, CO3, a weak mineral acid is a moderately strong base anion not removed by the cation attracting softener. Softened water is water where the heavy metals are removed. Soft water readily forms lather with soap, but it is more difficult to form lather with hard water, water with the metals dissolved in it. The dissolved calcium ions and magnesium ions in hard water react with the soap to form scum, so more soap is needed. The scum forms a film that coats the surface of your skin, dishes, windows, and other surfaces washed and rinsed with hard water. Softeners work by exchanging calcium and other heavy metals for sodium. A water softener does not remove the carbonate component of lime from the water. The sodium combines with the carbonate ion when the water evaporates to form sodium carbonate spots. However, the sodium carbonate compound is highly soluble whereas the calcium carbonate is not very soluble. So, when you wipe the sodium carbonate from the surface you are cleaning, with a towel or chamois skin, most of the sodium carbonate which remains in solution will come off with the water, whereas the calcium carbonate will start to precipitate out of solution onto the warm surface of the metal being washed. In summary, soft water can leave spots but not as visible, and wiping the surface will help if not eliminate the spotting. If the water you are passing through your softener is very hard, then the sodium carbonate level in the treated water will also be high, and harder to wipe off. Knowing the total hardness of the water being treated is very important. The calcium and other heavy metals remain on the softener resin bead until they are regenerated by passing high dosages of salt across the resin bead to push off the heavy metals and replace them on the resin. This is the softener regeneration process. The frequency of the regeneration process is based on the amount of total hardness in the water being treated. Demineralization. A water softener removes heavy metals only and replaces the metals with sodium. Softened water may not provide a spotless dry surface without manual wiping to remove the water. However, if a process is used that removes the heavy metals, the lighter metals, like sodium, plus the non-metal acids such as carbonate, chlorides and the like, then a spot-free surface can be achieved. There are two commercially and affordable methods to achieve the goal of ion removal. They are demineralization by ion exchange and reverse osmosis. Ion exchange. The ion exchange process involves the use of two different types of resin, cationic and anionic resin. The reason these resins remove most of the ions in the supply water is that the cation resin is regenerated with an acid to replace the metals with hydrogen. The anionic resin is regenerated with a strong caustic solution to remove the anionic acid ions and replace them with hydroxide ions. So, when the raw water is run through these resins, the hydrogen is exchanged for the metals while the hydroxide ions are exchanged for the anions. The results are a treated solution of H2O, nearly pure water. There are two technologies available, two-bed ion exchange and mixed-bed ion exchange. The advantages lie in the capacities, ease of transport and in some applications purification quality. This article focuses on mixed beds or mixed resin deionization. The mixed bed is easier to manually transport and fill. The use of mixed resin treats the incoming water to a lower TDS than a two-bed spot-free DI. The two-bed DI will have a slightly better capacity before the resin needs to be changed out. Both will produce spotless rinses, but both are expensive to operate in comparison to a water softener. Reverse osmosis. This process removes ions using a semi-permeable membrane where water with salts is passed over the surface of the membrane under pressure. The pressure drives the water through the membrane, leaving highly concentrated water with the salt going to waste. This process needs electricity and storage to operate the pumps associated with the process. However, once installed, an RO is an economical method of treating supply water for rinsing surfaces requiring spotless finishes. Commercial car wash operation. If you go into a commercial manual car wash, you see a coin-operated control where you put your money into. Once you've paid, the water comes on. You typically follow the following steps with the two different water purities coming from the previous processes. The process goes. Initial mud rinse using soft water or untreated water depending on the way the owner plumbed the installation. Soap wash with softened water. Initial rinse with softened water. Final spotless rinse with demineralized water, typically treated by reverse osmosis. But, in some cases, by ion exchange demineralization. Summary. The best washing is done with softened water. However, a spotless rinse is not ensured. To ensure a spotless finish, a demineralization system is needed. We here at Mobile H2O can supply you both. Hydrotech Systems Company, Incorporated. Manufacturer of Mobile H2O products.